Okay, number 28, write the correct formula for dinitrogen tetroxide. Your prefixes, since this is a covalent compound, it gives you a clue. It says di, which means two, tetra means four. So nitrogen, two, oxide, oxygen, four. Answer is C. Number 29, what is the correct name for CaCO3? Look at your polyatomic ion chart. CO3 is a carbonate, so we can eliminate A, and we can eliminate only A for now, but what I really want to focus on is this says Ca, right? So it can't be carbon. It's got to be calcium carbonate or calcium 2 carbonate. The answer is B, because calcium is not a transition metal. Remember, transition metals are between groups 3 and 12. Those are the ones in the middle of the periodic table that get the Roman numerals. All the other ones do not. 30 says, what is the volume of 13.3 moles of oxygen gas? This one's a little tough because we can actually use ideal gas law to answer this question. So this question should say at STP because that's what we're going to assume. So ideal gas law is PV equals nRT. Okay, so we're trying to solve for volume, so that means we need to move P to the other side, and I'm going to erase P. So its volume equals nRT over P. N represents moles, and I was given 13.3 moles. Our R constant is always going to be 0.0821. STP, 273 Kelvin. Okay, remember STP stands for standard temperature and pressure. Standard temperature is 273 Kelvin. Standard pressure is 1. So guess what? P is 1. So when I plug this into my calculator, all I'm doing is 13.3 times 0.0821 times 273. That equals 298 liters as my answer. All right, we're almost there. It says, what is the percent composition by mass of oxygen in magnesium hydroxide? And it gives you the molar mass of magnesium hydroxide. So this becomes really easy because I do MgOH. Okay. I just have to put, actually, it makes sense to just go ahead and calculate the molar mass of magnesium hydroxide because that's our steps. So magnesium, there's 1, and the molar mass of magnesium is 24.305. Oxygen, there's 2 of them because of the subscript outside of the parentheses. So that's 2 times 15.999. Then we have hydrogen. There's 2 of them again because of that subscript, 2 times 1.008. So when I still have to do this, that's why just calculate the molar mass. This is 24.305. And then you can keep going if you're one of those students that really likes to make sure that everything is correct. Because technically we could have stopped there and said, okay, the mass of magnesium is 24, oops, go back, is 24.305 and then go ahead and divide the molar mass by there. But we're not that lazy, so we can do it. Okay, add it all up and it's going to equal 58.3 like they gave us. Okay, we know that from this step we take 58.3 and divide it by all of these numbers, okay? So, but I just have to calculate for magnesium, but y'all are extra and you like to check your work sometimes. So the next step is to go, okay, 24.305 divided by the molar mass, okay? And when I get that, I get 41 point, well, I get a decimal. I get 0.4168. And you know that's not right. I got to make it a percentage. So I multiply it by 100, which means move the decimal point twice. So I get 41.6. I see, well, when you round, I lied. I can hear y'all yelling at me, 41.7%. Okay. Now, of course, some of you will go through and say, oh, well, let me check the percent of oxygen, the percent of hydrogen, and make sure it all adds up to 100. Go ahead and do that if you have time. If you don't have time, you got to roll. Okay. All right, let's look at 32. It says if 250 grams of silver absorbs 1,500 joules of heat energy, what is the specific heat capacity of silver if the temperature increases from 35 to 85? We just learned this. It was the last topic we learned. The last equation, Q equals M times CP times delta T. Okay, I am solving for specific heat capacity. Okay, so if I'm solving for that, that means I got to move my variables to the other side. So Q over M times delta T equals CP. Okay, so let's plug. My Q, the unit is joules for heat. So 1,500 joules goes on top, divided by mass, 125 grams. And my delta T is, remember, temperature final minus temperature initial. So my final temperature, if this silver is heating up, is 85, because it's heating up to 85, minus the first temperature of it, which was 35 degrees Celsius. Plug that into my calculator. And y'all, this is going to be your multiple choice question. And sometimes we make little math mistakes. And I've always told you that I'm looking at your work for this question. Okay. And if I don't see work shown, you're not getting the points. Okay. If you do show the work, then I'm going to be able to award you some points. Plugged it into my calculator. I got 0.24 as my specific heat. And the unit for that is joules over grams per degree Celsius. Okay. Let me know if you have any questions about this last one, because it is going to be worth 2 points on your exam.